Welcome to the It Factor. We're Jemmy and Nye exploring a new blog post by Mr. Len Kaplan, CEO of CDML, a managed service provider in Queens, NY, offering network management, voice over IP and UCaaS, cybersecurity, compliance, IaaS, cloud solutions, and Microsoft 365 and Azure solutions. If you're a small business owner or manage IT for a growing organization, this episode is for you. So today we are jumping right into, well, what Mr. Kaplan is calling the next massive tech boom, and it's this really specific combination of two technologies.
That's right. He argues it's neuromorphic computing and edge computing, and that the revolution is going to start with wearables, the smallest things we use.
Right.
And that's really the mission for you listening. If you can grasp how these two ideas merge, you get a shortcut to understanding why all our devices are about to get faster, smarter, more private, and just drastically more energy efficient.
And that unlocks things for a business that you just can't do right now.
Exactly. It's not just a small update. It's a whole new architecture.
Okay, so let's unpack this. We have to start with the brain of it all, I guess. Neuromorphic computing. You said it's totally different from the chips in our phones. How?
Okay, think of a normal computer chip. It's like a super efficient accountant. It does tasks one by one in a straight line. But it needs a big burst of energy for every single calculation.
Very linear.
Very linear. Neuromorphic computing, though, is modeled on the human brain. It's a web of artificial neurons that all communicate in parallel at the same time.
So less like an accountant and more like an actual learning system.
Precisely. The key word is spiking. These processors use something called spiking neural networks, or SNNs. And unlike a normal chip that's always drawing power, SNNs only fire when there's relevant data to process.
They just wait.
They wait. They're dormant and hyper-efficient until they detect something important. We're talking about chips that can monitor things in real time using thousands of times less energy.
And that translates directly into what Mr. Kaplan lists for SMBs, for small and mid-sized businesses. You get instant responses, you can analyze complex patterns, and you have that extremely low power use.
Yeah, that's why you hear about things like Intel's low-heat chip. But the brain isn't enough. It needs the location. And that's where the second piece comes in, edge computing.
Which just means the processing happens on the device itself, not in the cloud.
Right. Instead of sending data to some far-off server, the intelligence is right there at the edge.
So why is putting these two things together so powerful, especially for a tiny device like a watch?
Because it solves three huge problems at once. First, latency is basically zero. The device has the answer already. It doesn't need to ask the cloud.
Okay, that's performance.
Right. Second, reliability. It works perfectly if you have bad Wi-Fi or no cell signal. Think a remote worksite or a factory basement.
And the third one, which feels like the biggest driver, especially for businesses that have to worry about regulations.
Privacy and security. The neuromorphic chip is designed to analyze raw data, but only extract what's relevant. The sensitive stuff, it often never even leaves the device.
That sounds great. I mean, it sounds incredible. But here's my question, and I bet a lot of IT managers are thinking this.
Go for it.
If all the smarts are now on thousands of individual devices, doesn't that make managing everything a nightmare compared to just controlling it all from the cloud?
That is an excellent point. And yeah, it does change the management style. It has to.
Mm-hmm.
But you're no longer managing a constant flow of raw data. Instead, your IT team, or a partner like CDML, manages the models on the devices.
The software brains.
The brains, exactly, and the secure pathways for the results to come back. You're shifting from managing data streams to managing a fleet of intelligent assets.
Which brings us to why wearables are going to lead the charge here. They have all these physical limits, right? They have to be small, they have to sip power, be secure, and work offline.
And this combination just ticks every single one of those boxes. It solves all their core engineering problems at once. Wearables are the perfect test bed.
So let's get into the practical side. The stuff Mr. Kaplan highlights for businesses with, physical operations, construction, healthcare, that sort of thing.
Let's take safety gear. A smart helmet. We're moving way beyond just GPS tracking. Imagine that helmet having a neuromorphic chip that provides instant hazard recognition.
So it could hear a machine making a weird noise, a pattern that means it's about to fail, even before a person could register it?
Precisely. Or think about fatigue monitoring for workers. The device learns your personal body mechanics, your posture, and it alerts you when your form puts you at risk of injury. All done locally, all privately.
What about in the medical field?
We're moving beyond simple alerts, like your heart rate hitting a certain number. The device can analyze the entire complex waveform of your heartbeat. It can spot a predictive warning that's unique to you and your history.
And because it's all on device, that intense privacy needed for something like HIPAA is just baked in from the start.
It's baked in by design.
Let's make this really concrete with the scenarios from the blog post. The first one is off-grid health monitoring. So you've got a hiker or maybe a remote utility worker. They're completely off-grid. They're wearing a health band that has spent weeks learning their unique heart patterns. And as they're climbing, the wearable detects a tiny irregularity in their heart rhythm, something a normal device would just miss or think is just exertion.
But this device knows better because it's personalized.
Exactly. The key is the intervention. It gives an immediate silent warning to stop, to rest. And that action is only possible because all that complex analysis happened right there on the wrist. No cell signal needed.
That independence is the real business value. Now let's switch to the industrial one. Scenario 2. Autonomous hazard detection. This is for any small business in manufacturing or field maintenance.
Okay, so a technician walks into a factory wearing a smart helmet. The chip inside has learned the sound and vibration patterns of thousands of hours of safe machine operations.
Right, so the tech walks up to a conveyor belt, and the helmet instantly detects a vibration pattern that doesn't match any of the safe ones. It's subtle, but it's wrong.
And the alert is instant.
Milliseconds. It tells the technician to stop, to stand back, right before a bearing seizes or something catastrophic happens. It moves safety from being reactive to being truly predictive.
So these examples make the value clear, but let's talk about the bottom line. The dollars and cents for an SMB. What advantages does Mr. Kaplan list?
First, you get analytical power that used to be only for huge corporations with massive cloud budgets. Second, you get those real-time insights without having to build and pay for the complex cloud infrastructure to process it all.
Which means lower operating costs, better efficiency.
Exactly. And that ties right into compliance, which is a growing headache for everyone. Local processing gives you way stronger privacy controls. We mentioned HIPAA for health data.
Right, but the post also mentions DFS and GLBA. Can you quickly break those down?
Sure. DFS is the New York Department of Financial Services. They have very tough cybersecurity rules. And GLBA is the Gramm-Leach-Bliley Act, which is a federal law about how financial companies protect consumer data.
And the common thread is?
The common thread is data movement. If you can analyze sensitive financial or health data without it ever leaving your device, you shrink your risk and your regulatory footprint. Compliance becomes a feature, not an add-on.
So what's driving this convergence now? Why is this all happening so fast?
It's a perfect storm, really. AI models are getting smaller, wearables are becoming standard business tools, not just gadgets, and new privacy laws are actually encouraging this kind of local processing.
And the hardware makers are pouring money into it.
They are. The chips are getting cheaper, faster, and safer all at once. When that happens, a market shift isn't just possible, it's inevitable.
Which means businesses need to prepare. And that's where a firm like Mr. Kaplan's CDML comes in. They help organizations integrate these new tools safely, build the right kind of cybersecurity, and stay compliant with all those rules we just talked about.
It's about more than just the devices. It's about making sure your whole infrastructure is ready for the shift to the edge.
We've covered a lot of ground today, from brain-like chips to the future of workplace safety. If you liked this deep dive into the future of intelligent devices, please click the thumbs up button.
And remember, new blog posts come out every Tuesday and Thursday, so you can keep up with these shifts as they happen.
We invite you to visit cml.ae.com and subscribe to our blog to stay informed. Till next time.